I'm David Karoly, and I'm a professor at the University of Melbourne in Australia. And we know from lots of different pieces of evidence that the climate system has warmed and is continuing to warm. We can look at the increases in air temperatures, we can look at increases in ocean temperatures, as well as other pieces of evidence. And all these are indicators that the climate system, the planet, has warmed over the last 100 years. But some people say, well, we know that the Earth, that the planet has warmed in the past. We know that there have been periods when the planet has been a lot colder, ice ages, and also periods in the past when the planet's been much warmer. So how do we know that this warming of the climate system is due to human influences and not just natural variability? And what we can do is look at the different indicators, different pieces of evidence to try to assess whether the changes that we're seeing over the last 100 years in the climate system are actually consistent with what we would expect from the human causes of climate change, or whether they're just due to natural variability. And there are two things we have to look at. The first one is whether the increases in carbon dioxide that we've observed in the atmosphere over the last 100 years are due to human influences or not. We then have to make an assessment. Are the increases in carbon dioxide actually causing an observed warming in the climate system that we would expect, but we don't know? It could be just natural variability. So let's start by thinking about the observed increases in carbon dioxide in the atmosphere. And we also know that in the ice ages, there's been much lower carbon dioxide, and in intervening warm periods in between the ice ages that have occurred over the last 800,000 years, that the carbon dioxide concentrations were much higher. So we know that a warming climate system is linked to increases in greenhouse gases, but in the ice age and interglacial cycle, actually the carbon dioxide variations lag behind, occur after the warming. And there's plenty of evidence for that in different indicators, like the ice cores in Greenland and the ice cores in Antarctica. So we know that a warmer climate system can lead to more carbon dioxide. So maybe, some people say, the warming that we've observed over the last 100 years is actually causing the increases in carbon dioxide. How do we know that those increases in carbon dioxide are due to human influences, are due to burning fossil fuels? Well, there are lots of different lines of evidence. The first one is that if the increases in carbon dioxide in the atmosphere were due to just the warming of the climate system, we'd be expecting the same sorts of changes in carbon dioxide and isotopes of carbon in carbon dioxide to remain the same over time. Isotopes of carbon are essentially different atoms of carbon with slightly different molecular weights. The most common atom of carbon, the common isotope, is carbon-12. But we also have a much more rare version of carbon, which naturally occurs with more neutrons in it. And it's carbon-13. It occurs naturally. And what we find is that when carbon dioxide is produced by plants, including in fossil fuels that we're digging up, there's less carbon-13 than there is carbon-12 naturally occurring. So when we're burning fossil fuels, we would expect the atmosphere, the carbon dioxide that comes out from burning fossil fuels, to contain less carbon-13. Whereas if the carbon dioxide was just coming out of the ocean, there'd be no long-term change in the amount of carbon-13 to carbon-12. Scientists have been monitoring this ratio of the amount of carbon-13 in the carbon dioxide to carbon-12 in the carbon dioxide in the atmosphere, and see long-term declines. And that long-term decline is exactly what you'd expect from increases in fossil fuel burning and the carbon dioxide coming from burning fossil fuels, and not what you'd see from carbon dioxide just coming out as the ocean warms. There's another line of evidence we can use to look at. When we burn fossil fuels, in fact, when we burn anything, when you burn wood, we need oxygen. Because when we burn carbon, we need the oxygen, and it combines with the carbon to form carbon dioxide. So we'd expect, if there was increases in carbon dioxide from fossil fuel burning, that there would be matching decreases in oxygen in the atmosphere. And we go and monitor the amount of oxygen in the atmosphere, and there have been tiny decreases in the amount of oxygen in the atmosphere. We're not going to run out of oxygen anytime soon. You don't have to worry about that. But we do notice from detailed observations all around the planet that the decline in oxygen in the atmosphere exactly matches increases in carbon dioxide and what we would expect from burning fossil fuels. So those two lines of evidence show clearly that burning fossil fuels has been the cause, the dominant cause of the increases in carbon dioxide in the atmosphere. In addition to burning fossil fuels, we also know that land clearing, cutting down vegetation, has also been critical in the increases in carbon dioxide in the atmosphere. So we've seen then that carbon dioxide increases are due to human activity, human influences, burning fossil fuels and land clearing. But now we've got to look, have those increases in carbon dioxide caused the warming? Or is it just natural variability? And in fact, people say, quite correctly, that the dominant factor warming the climate system is normally increases in sunlight from the sun. When we go outside on a sunny day, it's much hotter than it is on a cloudy day. We know that nights are cooler than the daytime because there's no sunlight. So we know that the sunlight from the sun is the dominant warming influence day to day, from winter to summer, and in our climate system. So they say, well, maybe the increases of temperature that we've seen over the last 100 years are due to increases in sunlight from the sun. So how could we assess that? Well, one way to think about it is there's actually not a lot of sunlight shining at night. In fact, there's no sunlight at night. That's why it's nighttime. So if the sun was getting stronger because the intensity of sunlight was getting stronger over the last 100 years, we'd expect more warming in the daytime than in the nighttime. That's just common sense. When we go and look at observations of daytime temperatures versus nighttime temperatures, we actually observe more warming in nighttime temperatures, or a larger rate of warming in nighttime temperatures than daytime temperatures. And that's exactly what we would expect from increasing greenhouse gases in the atmosphere. We see the same sort of thing in summer and winter temperatures. While the sun is stronger in summer, because the sun's more directly overhead as the Earth orbits around the sun, in summer we're actually seeing less warming on average in summer than we are in winter. In fact, the rate of warming is larger in winter. And again, that's exactly what we would expect from increases in greenhouse gases in the atmosphere. And there's one final indicator. When we look at the vertical patterns of temperature change in the atmosphere, if the sun was getting stronger, sunlight is absorbed in the upper atmosphere by the ozone layer and by oxygen in the upper atmosphere. And if the sunlight was getting stronger, we would expect warming in the upper atmosphere, as well as warming in the lower atmosphere and at the surface. Now, when we go and look at observations over the last 50 years, we see decreases in temperatures in the upper atmosphere and warming in the lower atmosphere. And that's a fingerprint of climate change caused by increasing greenhouse gases. Increasing carbon dioxide in the atmosphere causes decline in temperature in the upper atmosphere and increases in temperature in the lower atmosphere. Whereas if it was increases in sunlight from the sun, we'd see warming in the upper atmosphere. So we can look at all those indicators, the differences between daytime temperatures and nighttime temperatures, the difference between winter and summer temperatures, and the differences between temperatures in the upper levels of the atmosphere and the lower levels of the atmosphere, and they're all exactly what we would expect from the increases in carbon dioxide and other greenhouse gases causing the warming, and inconsistent with increases in sunlight causing the observed patterns of change. And now we can conclude that human-caused burning of fossil fuels, as well as land clearing to allow more agricultural land, has led to the increases in carbon dioxide in the atmosphere. And those carbon dioxide increases in the atmosphere have been the major cause of the observed warming of the climate system over the last 100 years. It is clear that human activity has been the dominant cause of global warming that's been observed over the last 100 years.